Hello students. So today we will learn about the forces acting in helical gear. Okay. So if we see the diagram which is related to pinion and gear, we know that if the size of the gear is less, then we call it as pinion, and if the size of the gear is greater, so it is called as gear or wheel. Okay. So in this case, this is act as a pinion. Observe this diagram. Okay. If we see here these three lines are nothing but indication of teeth. Okay, helical gear teeth. So helical gear teeth is inclined like this. If we observe this gear from the front side, okay, sorry, from the front view, if we observe, then we see the gear is like this, and if we observe from the side view, right hand side view, then the view is like this. Actually, teeth are there. So actual gear is like this. Okay, teeth are there, but here for the purpose of explaining the forces, only this type of diagrams are drawn here. Okay, so this is right-handed. If the inclination is like this, from left towards the right side, like this, then this is called as right-handed gear. And if the inclination is like this, then this is called as left-handed gear. Okay. And if we observe the direction of rotation, okay, direction of rotation is like this, okay, and the FA is towards the right in this case, driven, and in case of driving pinion, the force direction is towards the left, okay, and if we see this driving gear, the FT and radial force is also shown in this case, and here also in second diagram, that is in case of driven gear. Okay, so if we generally say how much forces acting in case of helical gear, so three different types of forces are acting. That is tangential force, radial force, and axial force. Then if we compare these forces with spur gear, then in case of spur gear, only two different types of forces are acting. That is tangential force and radial force. But in case of helical gear, one more force is acting, that is axial force, or it is also called as thrust force. Okay, so why this extra third force acting in this case? Because of this inclination of the teeth. Okay, as the teeth are inclined to with the axis of the shaft or with the axis of the gear, so for that purpose, one more extra force is acting here, that is axial force or thrust force. Okay, so our one more basic question is came in your mind that out of these three different forces, which force is important and which forces are not important. So if we compare the first force, that is radial force, and if we observe this free body diagram, so for this FR is acting towards the upward direction, and here this FR is acting in downward direction. So actually this FR, that is radial force, is try to separate this gear. But whether this is desired to us, our answer is no. This is not desirable because FR if acting in opposite direction, then it is tries to separate these gears. So this is not desirable condition. Okay, we want to make in contact with each other. Okay, this is our aim, but this is tries to separate out. So this is actually not desirable force, but due to this resultant reaction or resultant force, the resultant force is inclined, and that resultant force makes these two components, that is tangential force and radial force. So actually resultant force acts on the gear, and this is separated into two different components, and due to that this radial force came. Okay, this is the reason. So it is not avoidable, but as it is negligible, so we neglect this force in case of our design calculation. If we see axial force, this axial force came due to the inclination of the teeth. But whether this axial force is desirable or not desirable, this axial force directly came from this inclination or due to that inclination, and it goes in that shaft, and ultimately it goes towards the bearing. Okay, and then it affects on the bearing, or it increases the bearing load, and after some period it tries to fail that bearing. Sorry, it tries to increase the load on the bearing, and ultimately the bearing life decreases. Okay, so this is the not desirable force, this axial force. So whether any method is available to avoid this axial force, because it directly affects on the bearing, and ultimately the bearing life gets affected. So yes, if this is single shaft and you use the right handed gear, then on due to that right handed gear the axial force is like this, and if on the same shaft if we use again one more helical gear, but which is in opposite hand of helix, that is left handed, this inclination if we observe on the gear, then this is called as left handed, and if this is left handed, the axial force is always opposite to right handed. Okay, so same magnitude is there, and due to that same magnitude but directions are different, these two forces cancel each other, and ultimately the bearing life increases because these two forces cancel each other. So that load which is increased on the bearing, when it acts on the bearing, that is not affected, or due to that axial force it is not affected. Okay. Now if we see the tangential force. The tangential force is very important force, and this is the only force which is really useful to us to transmit the rotation from one gear to another gear, or to transmit the torque from one gear to another gear, or to transmit the power from one gear to another gear. Okay, so tangential force is only the force which is actually important to us to transmit the power, okay, or to transmit the rotation. So these three different forces are acting. Now how to calculate the magnitude of these forces, we see one by one. After discussing this formula, then we shift on the directions, how to decide the directions of these three different forces. So first I want to explain these relations. So first is tangential force. Tangential force is equal to power upon velocity. Power which want to transmit from one gear to another gear, or from motor to the output shaft. Okay, that power we substitute here. Then next is divided by V. V is called as pitch line velocity. V is equal to pi dp and V upon 16 to 1000. By using this relation, we easily calculate the value of pitch line velocity. Okay, then if we have the value of torque, then also it is easily calculated the tangential force. Tangential force is equal to torque upon radius. So torque in this case, two different gears are available, that is pinion as well as gear. So if we take the torque acting on pinion, that is Tp divided by dp by 2, which is equal to Tg divided by dg by 2. Okay, so by using this relation, we are able to calculate the tangential force. Second is radial force. So if we already calculated tangential force, then only by using some relations we are able to calculate the radial force. That is Fr is equal to Ft into tan phi t. What is this phi t? Phi t is pressure angle in case of transverse plane. Okay. Then Fr is equal to Ft into tan phi n upon cos psi. Okay. Why we written here this? Because one more relation is available, that is tan phi t is equal to tan phi n upon cos psi. So by using that formula, we just substitute the tan phi t value here. So F1 is equal to Ft into tan phi n upon cos psi. So where this phi n is pressure angle in case of normal plane, psi is helix angle. After calculating this radial force, it is also possible to calculate the axial force. If we know the tangential force, just use this formula. F is equal to Ft into tan psi. Okay, again psi is helix angle. So by using these different relations, we are able to calculate these three different formulas. Okay, now we shift to next stage, that is how to decide the directions. So for deciding the directions, if we observe these diagrams, these are very useful. Okay, this is actually in contact with each other, but for understanding purpose, we draw this diagram separately. So it is also called as free body diagram. Okay, if we see the tangential force first. Okay, so in case of tangential force, if we observe the direction of rotation, so observe which is driving gear and which is driven gear. In this case, this is driving gear and this is driven gear. So in this driving gear, this turns in clockwise direction. Okay. Now always see whether that is driving gear or driven gear. If that is the driving gear, then this tangential force tries to oppose this direction of rotation. So if we see, this is anti-clockwise direction. So this tangential force opposes this anti-clockwise direction. Okay, and in this case, this Ft opposes this anti-clockwise direction. Like this gear turns in this motion, and this tangential force opposes to that. Okay, so this is about the driving gear case. But if we see the driven gear case, in case of this. This is the direction of rotation. Direction of rotation is anti-clockwise direction, and in this case, tangential force supports this direction. Okay, this tangential force supports this direction. So this is about the driven gear case. So in this way, we decide the directions for tangential force. Okay, and now if we see the directions for radial force. So in case of radial force, the directions are always towards the center of the respective gear. So in case of this upper gear, we want to show the radial force. The radial force is always acting towards the center of the respective gear. Respective gear is upper gear now. So the center point is at the upper most point. So Fr force is acting on the upward direction. If we see the radial force for downward or for the lower gear, in this case, radial force is always acting in downward direction because center point is located in downward direction. Okay, so this is about the radial force direction. Now, third force, that is axial force, or it is also called as thrust force. For that, if we observe this diagram, then it is very easily understood. Okay, so in case of axial force or thrust force, understand some rules. Okay, first observe which is driving gear. Find out that which is driving gear. Okay, suppose this upper gear is called as driving gear. Second rule, then check whether it is right-handed or left-handed. So in this case, this is right-handed. Okay. After that, you use your right hand if the gear becomes right-handed. If the gear becomes left-handed, in that case, naturally you use your left hand. Okay. So in this case, driving gear is this, and the gear position or hand of helix is right-handed. So you use your right hand. Okay. Then observe the direction of rotation of that gear. In this case, this direction is easily observed from the right hand side. So observe this direction of rotation. So direction of rotation is like this. So you curl your fingers in same direction. So in this case, direction of rotation is like this. So you curl or turn your fingers like this. Okay, like this. In this case, the gear is rotating like this. So fingers are also in this condition. Okay, and keep your thumb in that is in parallel with this axis. Okay, in parallel with this axis. So in this particular case, our thumb is on the left side, so axial force direction is towards the left side. Okay, in this way we are easily decide the directions of this that is forces, helical gear forces. I want to revise that how to decide the directions. Formulas already on the board. You use this formula and directions, radial force or tangential force first. So in case of tangential force, observe whether that gear is driving gear or driven gear. In case of driving gear, you always mark that tangential force which opposes the direction of rotation. Okay, and in case of driven gear, you mark the tangential force which is in the position of supporting that direction of rotation. Okay, this is for number first. Radial force is always acting towards the center of respective gear. So in this case, for upper gear, radial force direction in upward direction. For downward gear, radial force direction in downward direction. Okay, and for axial force or for thrust force, some rules are there, like choose first or observe which is driving gear. In this case, this upper gear is driving gear. Then observe whether it is right-handed or left-handed. So in this case, this is right-handed. So we use your right hand. Okay. Then check the direction of rotation. In this case, from the right-hand side, we are easily observe the direction. Direction is like this. You turn your fingers in same direction. Okay, and you keep your thumb parallel to the axis of the gear. Okay, and in this way we are getting the direction for axial force also. In this way we finish our discussion about the forces acting on helical gear. Okay, so we stop here. Thank you.